you through our project visualizing potential shuttle routes using the NYC taxi data. NYC sees millions of taxi trips every year. Many of these follow the same short routes, which leads to congestion, longer travel times, and higher emissions. Our goal is to spot this repeated high-demand corridors so the city planners or the shuttle operators can design shared routes that replace many individual taxi rides. We use the NYC yellow taxi data from 2023 to 2025, which is about 93 million raw trips, combined with taxi zone shapefiles. After cleaning and aggregating, we build a more manageable dataset of about 3 million group rows that still preserves the pickup and drop-off zones, timestamps, distance, and fare. On the method side, we have k-means clustering and dbScan clustering. K-means has 15 clusters. It gives a higher civiliot score. It covers 100% of the zones and produces compact, geographically meaningful areas. While DBscan finds some natural hotspots, but it overclusters dense regions and misses about 13% of the zones. We then group taxis by time of the day, which is morning, midday, evening, and night, and turn them into origin-destination matrices between the clusters. This lets us see not just where the demand is, but how flows between areas change over time. We have an interactive dashboard where users can filter by date and start hour and end hour. There are a total of 93 lakh strips, and we have the users can filter based on the flow maps on top and routes or the percentile cutoff. So let's go with the percentile cutoff, and the users can see the number of trips based on the clusters, the flow, and they can select a single color if they want. We have the k-means clustering map where the number of clusters is represented as dots and they are specially concentrated, and the size of the clusters represents the number of trips. We have a graph which shows the number of trips per day. We have a bar graph which shows the trips by the pickup hour. We have the top 10 origin destination pairs, which represents the most active origin destination pairs. We have an origin destination coverage curve, which shows how quickly the top OD pairs covers the multiple trips. Then we have a heat map which shows the k-means cluster connectivity. Then we have a heat map which shows the hourly intensity by the particular weekday. Then we have a 3D representation of the clusters versus the hours. Yeah. For evaluation, we looked at three things. The first one is the clustering quality. We compared k-means with dbScan, and k-means performed better, giving cleaner geographic clusters and covering all zones. Second one is scalability. We checked how well our origin destination matrix and the flow analysis scale by aggregating the trips into groups so we can handle tens of millions of records without breaking the system. The third one is usability. There were about 20 users who tried the dashboard and they liked the flexible filters and visible toggles for quickly spotting the patterns and only reported occasional slow reloads when changing the filters, which is expected at this data scale.